Hello and welcome to another GDB Watchpoint. Today we're going to show multiprocess debugging, that is debugging multiple inferiors at the same time from the one GDB, and some catch points as well to make this work. I'm going to debug bash in this demo. I don't have source code or debug info installed for bash on this machine. Still, you can get a lot of interesting information out of GDB with release binaries that don't have that debug information. So let's see how we do this. So if I echo $$ here, this gives me the PID that this bash is running on, right? So that's the PID. So GDB -p, paste that PID there. Here we go. I've now attached to my bash. So if I try and type in this window, nothing happens. I just typed H 3 times, didn't see anything because I'm stopped in the debugger. Info proc, and sure enough, here we are. Look, here's my exe bash. So fine. Well, if I continue, I see sure enough those H's that I just typed popped out. Let's get rid of them. Don't want those. So let's throw now a catch point. So Control C in my GDB window, and I'm going to catch. Now you can catch various things, exceptions, and all kinds of things. But this time we're going to show syscalls. So catch syscall. If I tab complete, tab, it'll show all the syscalls that it knows about. So I can catch my syscall by name. I can give the syscall number if I know that. But name usually is what you want. So here are all the syscalls that we might want to catch. I'm going to catch the right syscall here now, nice and simple. So catch syscall right. That's syscall number 1 as it happens on x86-64. So good. So continue, and I'm going to switch over to my bash prompt, and I'm going to type the letter C. Now when I type the letter C, I'm not going to see it in my bash because of course, bash is going to echo each character that I type, and that's going to be a right system call. So here we go, C. Sure enough, my GDB has interrupted here. And if I go backtrace, I can see that it's in the right, libc call, which then is in the system call. So let's have a look at the disassembly, and we can see here we are. Look, yeah, sure enough, right after the syscall instruction. So we're actually inside the syscall. We're inside what Linux calls a syscall enter stop. So the bash process has entered the system call right, and at that point the kernel has returned control to GDB. By the way, little trick, if you want to know how do I know whether I'm actually inside the right syscall or just returned, well, there are a couple of things I can do. If I look at the RAX register, well, that will tell me -38. Now -38 happens to be the erno, negative erno, or enosys. No such system call exists. So this trick I think only works on x86, but if it says it's after this, either I've returned from that syscall and the syscall didn't exist, or I've gone into it. I can see the line above that I've probably put 1 into EAX. So this is probably inside the syscall. If I really want to know, I can look at orig RAX, original RAX. That tells me the syscall number that I put in, right? So sure enough, put in syscall number 1, and we're stopped inside that right syscall. So now when I continue from here, what we'll see is the letter C pop out here. So let's continue, and sure enough, there's the C, right? Let's delete that catch point. That's going to get really annoying if we stop every time my bash tries to write anything. So delete that and continue. Actually, no, not continue, sorry, Control C that. So I'm going to put some different catch points. I'm going to catch, notice I did before catch syscall right. Well, I'm going to catch fork, but I'm not going to say catch syscall fork. I'm going to say catch fork. That's because actually there are a number of different fork type system calls. There's the fork syscall, the original. There's clone. There's clone 2, and modern kernels have clone 3, and who knows, maybe I'm sure at some point in the future we will likely to get clone 4. So if I just catch fork, that would put a catch point on any fork-like system call, and similarly for exec, for the various flavors of exec. Okay, so now I'm going to continue my GDB. So now I can type at this, so I've removed my right system call, so this will work. Okay, so cat, I'm going to go etc. issue, it's going to cat a small file that I think probably exists. Enter. Okay, so now this has stopped, my bash has stopped, and if I go back to my GDB, I can see, yeah, we've stopped in the fork. Let's go disassemble. So we are again just inside this fork syscall. We're in the syscall enter stop at this point. backtrace, I can see the same. Look, yes, I'm in the fork, all good. So if I go info inferiors, what we see is there's still only one process because I haven't completed the fork system call yet. But if I were to complete that fork system call, it's going to, what GDB will do by default is it will detach from the child forked process and just let that run. That's not what I want to do here. I want to debug both my bash and my cat process like at the same time. So set detach on fork off changes that default behavior. So now when I do ni, or let's do the full thing, next I, next to step over that syscall instruction, I could also step I, it would be the same here. We will see, there we go. Now we have genuinely returned from the system call. And so info RAX, print RAX will give me the PID because I'm in the parent process here. Info inferiors will tell me that. Okay, so now I've got two processes, right? Two bashes because bash is forked, the parent and the child. So if I just continue the parent, not a lot happens, right? Let's Control C, see what we've got to. Now I've moved. It's no longer at fork. Look, it's in wait 4 here. So if I do BT backtrace, I can see, yeah, I'm in the wait. So this is kind of what you'd expect. The bash process of forked the child process, the cat, and now it's waiting on cat. But I haven't continued the child, so that's just going to wait forever. Okay, so info inferiors, you can see that little star against number 1, so I'm in the parent. So if I switch to inferior 2. So this is just like when you switch threads with thread 1, thread 2, info threads, info inferiors, inferior 1, inferior 2, all works the same way. So now I've switched my inferior to the child process and I continue that. And okay, now it's hit the exec. Remember I had an exec catch point? So I can see that here. So it's exec user bin cat, exactly what we would expect. So info inferiors shows me now I've got one bash process and one cat process. All good. Continue that. So now we're in the child process, so I'm going to continue. Now that process has exited, and if I look on my bash here, sure enough, it's printed out the contents of etc issue, and so now I can just switch back to the parent inferior 1 and continue that. Now the wait will complete because the child has exited, and we go back to the bash prompt like this. So there you go, nice little example showing a few different things. We showed catch points, we showed a kind of pseudo catch points of fork and exec. We showed how you can usefully get interesting things out of debugging even without debug info or source code. And we showed how we can debug multiple inferiors at the same time from the same GDB. Thank you for listening. Until next time.